Hi everyone, welcome to my channel Chemistry Tutorials by Kiranmai. In last video, I discussed about Bohr's postulates, and in this video, I am discussing Bohr's theory for hydrogen atom. According to one of the Bohr's postulates, electrons revolve round the nucleus in circular path. These paths are called stationary orbits or stationary states. These stationary states are numbered. Stationary states are numbered. It is denoted by the letter n and is given the value 1, 2, 3 and so on. These integers are called principal quantum numbers. Principal quantum numbers. These principal quantum numbers gives us the information about the electron's position in the atom. If these principal quantum number increases, for suppose this is the nucleus and these are the stationary states. These stationary states are numbered as 1, 2, 3, 4 and so on. As these principal quantum number increases, the distance between the electron present in that state and nucleus also increases. So these are the stationary states. If electron is present in the first orbit, it is closer to the nucleus. If it is present in the second orbit, it is further more located from the nucleus. And if it is present in the third stationary state, it is furthermore located in the larger distance from the nucleus. And according to Bohr, the radius of these stationary states can be calculated by using the formula Rn is equal to n square A naught. Here n is the principal quantum number which has the value of 1, 2, 3 and so on, and A naught is equal to 52.9 picometers. If n is equal to 1, that is, for the first stationary state, radius can be calculated as R1 is equal to 1 square. So n square, here n is equal to 1, so 1 square into A naught, 52.9. So radius of first stationary state is equal to 52.9 picometers. First stationary state. Radius is equal to 52.9 picometers. This first stationary state is called Bohr orbit. Bohr orbit. See here, as the n value increases, r value also increases. R value increases as n value increases. See, this is the nucleus and these are the stationary states numbered as 1, 2, 3, 4 and so on. As these stationary states increases, the distance between the nucleus and this state also increases. So as R value increases, n value is also increasing. So these two are directly proportional. R value increases and then we can notice that n value is also increasing. Next, Bohr also gave another formula which is used to calculate the energy of electron present in these stationary states. En is equal to minus RH into 1 by n square joules. So here RH is the Rydberg constant. RH is Rydberg constant which has the value of 2.18 into 10 power minus 18 joules, and n is the principal quantum number which have the values 1, 2, 3 and so on. If we calculate the energy of the first stationary state, energy of electron present in first stationary state, then E1 is equal to minus 2.18 into 10 power minus 18 into 1 by 1 square, which is nothing but energy of electron present in first stationary state is equal to minus 2.18 into 10 power minus 18 joules. This is the energy of electron present in the first stationary state. Here we are assigning negative values to the energy. This is because if we consider the electron present in the stationary state which is closer to the nucleus, and if we consider the electron which is farther away from the nucleus, let it be at n infinity. Here this electron experiences zero nucleus effect on it, whereas this electron is fully influenced by the nuclear attraction. Here literally there is no nuclear attraction. At this point, energy of the electron will be zero. At n infinity, energy present in this orbit is zero. And then if electron moves closer to the nucleus, means it should jump from higher energy level to lower energy level. According to one of these postulates, when electron moves from higher energy state to lower energy state, it should decrease its energy. So anything below zero means it should acquire a negative value. So we are giving the energy present in these energy of electron present in these stationary states as negative. These are the two formulas. Rn is equal to n square A naught and En is equal to minus RH 1 by n square joules. These two formulas are used to calculate radius of the stationary state and energy of electron present in these stationary states. Bohr also gave formulas for the species which are isoelectronic with hydrogen. Isoelectronic with respect to hydrogen. Hydrogen have one electron. Those species which have only one electron in them are considered as isoelectronic with respect to hydrogen. Suppose helium ion generally helium have two electrons. If it acquires one positive charge, it have only one electron. Similarly, lithium 2 plus which have only one electron in them. Similarly, beryllium 3 plus, it loses 3 electrons in, then it will have only one electron in it. Helium, lithium, beryllium, when they are unipositive, dipositive and tripositive respectively, will be isoelectronic with respect to hydrogen. For these species, to calculate the radius, we use the formula given by the Bohr. Rn is equal to n square A naught by Z. Z is the atomic number of these species. For helium it is 2, lithium it is 3, for beryllium it is 4. Rn is equal to n square A naught by Z. And similarly, energy of the electron present in stationary state can be calculated by using the formula En is equal to minus RH Z square by n square joules. So here is Z is the atomic number, n is principal quantum number, RH is the Rydberg constant. And then Bohr also predicted the magnitude of velocity of the electron which increases or decreases based on the nuclear charge and the distance between the electron and the nucleus. So here the magnitude of velocity of electron present in a stationary state increases with increase in positive charge of nucleus. As the nucleus positive charge increases, that is, if the nucleus have more number of protons, then the velocity of electron in the stationary state increases, but the velocity of the electron decreases with increase in the principal quantum number n. So here, if n value increases, velocity of the electron decreases, and if the positive charge of the nucleus increases, velocity of the electron increases. So this is the Bohr's theory for hydrogen atom. So according to Bohr's theory of hydrogen atom, stationary states are numbered, and these numbers are called principal quantum numbers. He gave the formula for calculating the radius of the stationary state, that is Rn is equal to n square by a naught, which is measured in units picometers. And he also gave the formula for calculating energy of stationary states. En is equal to minus RH1 by n square joules. And then the species which are isoelectronic with hydrogen, we can calculate their radius by using the formula Rn is equal to n square a naught by z, and energy of the electron present in stationary state using the formula En is equal to minus Rh z square by n square. And the velocity of the electron increases with increase of positive charge of the nucleus, and then the velocity of electron decreases with increase in the number of the stationary state, that is the distance between the electron and the nucleus. If the distance between the electron and nucleus increases, the velocity of the electron gets decreased. This is the theory of Bohr, with the Bohr given for the hydrogen atom. If you understand this video, like this video. If you have any doubts, comment in the comment section. If you think it is useful for your friends, share with your friends. Thank you.